demonstration, we're going to look at how a torque converter works. We're going to look at the principles of a torque converter. Okay? The components, you guys got to see the components this morning. You saw the terms on there. We're going to talk about those components when we go back into the classroom. But I want to explain to you guys how a torque converter works. Does anybody know how it works? You want to explain to me? Anybody? Raise your hand. Okay, so Stryker's saying pressurizes fluid, acts very similar to a clutch in a manual transmission. He's not too far off. It is using fluid. It does act like a clutch in a manual transmission. The only difference is we're not pressurizing fluid, we're moving fluid. Okay, we're moving fluid. So our two fans are going to act as our torque converter this morning. One is going to be a drive fan. So one is going to be what is attached to our engine flywheel. Okay? The other one is what we call our turbine. It's the free fan. It's the one that's going to actually drive the transmission input shaft. So one of them is being driven by the engine. The other one is attached to the input shaft of the transmission. Okay? And as we start the vehicle up, we know that the vehicle doesn't move when we hold our foot on the brake. So this one, even though the engine's still rotating and spinning, this one isn't moving yet. Okay? So what we're going to do is kind of turn it on and see what happens. Alright? Initially, as you turn it on, you'll see that our turbine starts to spin. This is our impeller. Impeller, turbine. This is our drive. This is our driven. Okay? So impeller is, again, the one that is part of the case. It's part of the housing. So a torque converter has two different finned objects inside of it, just like fan blades. The one fin is attached to the torque converter itself. And so it spins as soon as the engine started. Again, this is our drive, this is our driven. Okay? Now you'll notice my engine, I'm sitting here and I'm idling, right? Okay? So I'm idling. If I were to step in between it and start to block airflow, what do you notice about this fan? Is it slowing down? A little slower, a little slower, a little slower, right? Okay? So, if I could vary the speed of this fan here, if I could vary the speed of it, change the speed of how fast it's turning, okay, I can either stop or slow this here. So a torque converter, the way it works, at idle, okay, at idle, a typical engine idle is what RPM? Speak up. 750. 1,000's actually high. 750, 850, that's usually where we want idle on a car. Next time you guys are driving your vehicle and it's at idle, look at the tachometer if you have one. It's probably going to be around 850. If you're above 850, you want to think about adjusting it. Okay? So about 850 RPM. Torque converters usually don't take off and start working until 1,200 RPM. Alright? So that means we got to hit the gas in order to get this vehicle to propel, get it to move, right? So if I'm sitting here at idle, this driven fan can spin all day long at idle, and it's not going to drive this fan, okay? Because it's not moving enough air to actually get this fan to move. So if you can block it off, right? Get my keys caught in there, it'd be exciting, wouldn't it? Okay? If I can block it off, essentially what's happening is my engine's still running, but I'm at idle. I'm not turning my impeller fast enough to drive my turbine. Okay? But the faster that my impeller spins, the more air I move, or the more fluid I move, it's turning my turbine. Okay? I'll grab these boxes and help me out real quick. Grab that one, grab the duct tape on the bumper. Who's got questions yet? Which one is the drive fan?
The impeller.
Okay? The drive fan is the impeller. The driven fan is the turbine. We have an impeller and turbine. What do we know about the size of them? You guys guys have any idea about the size of them? You think they're the same size? You think one's smaller than the other? What do you think?
Are we talking metaphorically?
No. No, the real thing, the real deal. You gotta imagine that this is the principle of what's happening inside the torque converter. Same thing. Instead of moving air though, we're moving fluid. Okay? So if you just, in place of the air that's being moved, if you were to envision fluid instead of air, that's a torque converter. Okay? The impeller and turbine are pretty much the same size when it comes down to internal components. Okay? Now the turbine, remember the turbine, we looked at a torque converter last week. The turbine is part of the torque converter case, or the torque converter housing. Okay? The impeller spins freely, springs separately. All we're trying to do here is more or less build ourselves a housing. Okay? A torque converter is inside a housing. These impellers are inside an enclosed housing. So it means the fluid, in this case the air, is going to be forced not to move outside. Okay? We're building a housing. It's forced directly straight across from our impeller to our turbine. So that's what we're creating. We're creating a housing. The part you see when you pull a transmission out, you see the torque converter housing and not the internal components. So that's what we're creating by our handyman's secret weapon, duct tape and cardboard. Okay. Now let's see if we notice a difference in our fan speeds. Okay? We'll kick on our, what is this one again? As we start the engine, it starts turning the impeller. Let's see what it does. It takes it a minute, doesn't it, to kind of get up to speed. So when you take off from a stoplight, it does the same thing. It's going to take it a minute. A torque converter has a certain amount of slip to it because it's fluid that's starting to drive this turbine. Okay, it's fluid that's driving it. So it does have a certain amount of slip to it. There's no solid clutch plates like in a manual transmission. It's turning it quite a bit faster, isn't it? Okay? The faster this spins, the more directly related this will spin, right? So right now it's not turning very fast. We have a whole bunch of open gaps up here, down here. But if we were to take all the air that our impeller is putting out and put it towards our turbine, it would drive at the same speed. Does that make sense? Okay. So if we were to completely enclose and have no air leaking, as fast as this is spinning and this is spinning at 1,000 RPM, this would be spinning at 1,000 RPM. Okay? So the faster I spin this, the faster I spin this. So a torque converter, it uses fluid drive, right? Questions on what we're looking at here. Questions on how this correlates. Pretty simple. If you got it, raise your hand. You got kind of the